most of these answers correct, but the fact that there were multiple possible answers kind of stymied some people. I got a couple of extra answers that were incorrect, and sometimes people missed things that were in there that should have been selected. So, for instance, which of the following are nominal or categorical variables? Nominal, categorical, basically another way of saying the same thing. Okay, country of origin. That's a name, right? Country is a name, so I would check that off and say that that is a nominal variable. How many siblings do you have? Nope, that's a number. Do you smoke? That's a yes or a no. Okay, just like male or female, a selection like that is going to be a nominal variable. It's a category. Yes or no is basically a category. How many cups of coffee do you drink? Again, that sounds like a number. What's your blood pressure? Sounds a number. Now, this is one that many people got wrong. How would you rate the MPH program? Excellent, good, fair, or poor? Well, they're categories, but they're special kinds of categories. Anybody know what kind of variable that is? Anybody want to let me know what that variable name is? Okay, ordinal, exactly. Anything that has a series of categories, whether it's 1 to 10 or poor, fair, good, excellent, that where the difference in the values is has order. In other words, one thing is greater than the other. For instance, in this case, fair is better than poor, good is better than fair, excellent is better than all of the rest of them. If we're talking about the pain scale, how much pain are you in from 1 to 10? Okay, 3 is less pain than 7 is. Now, so that's an ordinal variable. Both of those are examples of ordinal variables. Now, one of the properties of ordinal variables, although they have order, we don't really know the difference between that and with the pain scale. We wouldn't consider that a numerical variable, even though it's expressed as a number, because the difference between a level of 2 pain and a level of 3 pain may be different than the level 7 and 8, the difference between 7 and 8. We have no way to measure whether the difference is the same or different. So we consider that a form of a categorical or numerical variable called an ordinal variable. Okay, so those are the two that I would have. A lot of people chose as a nominal variable, they chose rating the MPH program. Kind of right, but it's more correct for it to be an ordinal variable. I only took a point or two off if you added an extra one or deleted or left one out. What are the following? Which of the following are discrete variables? Discrete numerical. I put scalar in there because SPSS tends to use the term scalar for numerical variables rather than numerical. Discrete means integer, basically, or really a special kind of integer, things that you would express as units or small integers, for instance. Not every integer. For instance, blood pressure frequently is expressed as an integer, but I'll get to that in a second. So not country of origin. How many siblings do you have? Well, that's certainly an integer. You're not going to have 2.5 siblings, right? Do you smoke? That's not numerical. How many whole cups of coffee did you drink this week? Well, yeah, I drank 12 cups of coffee this week. Again, that's an integer. The key there is whole. If I asked you what the average number of cups of coffee you drank this week per day, well, that may not be a discrete numerical variable. That may just be a numerical variable because the answer to that might be 2.5 cups or 2.3 cups or 7.2 cups and so on and so forth. So how many whole cups of coffee did you drink? That's kind of a tip-off that is discrete numerical. What's your blood pressure? Well, a lot of people chose that because they're used to seeing blood pressure expressed as a number. Oh, your blood pressure is 120 over 80. Well, really, blood pressure is a continuous scale. Most doctors don't bother to, unless they're recording something off a digital device, they don't bother, expressing it beyond whole numbers. But your blood pressure could be 89, it could be 90, or it could be 89 and a half, or any value in between those two, right? So that's not really a discrete numerical variable. So a lot of people did choose that, okay, and we already know about the last one. Okay, so those two are the correct responses. Which of the following are numerical scalar variables? Again, scalar because that's the term SPSS used, and I want to make sure we know it. Not including discrete numerical variables. What's the average number of cups of coffee? Well, I just gave that away, didn't I? So it's the average. It's possible to have numbers that are decimals or in between integer numbers. So I'm going to check that off. What's the blood lead level for a child in micrograms per deciliter? Well, that's numerical. That could be 5, could be 7.3, it could be 1, and so on and so forth. Do you smoke? Nope, doesn't look like it. How many whole cups of coffee? I said exclude discrete numerical, so we're not going to check that one off. What's your blood pressure? We just discussed that. That's going to be a numerical variable. How would you rate the MPH program? Not going to be that. So those 3 are the correct selections for question 3. Question 4, which of the following are ordinal variables? And now we know what to look for in ordinal variables. What's your country of origin? On a scale of 1 to 10, what level of pain are you experiencing? Sure enough. What is that? Anybody know what that scale is? That scale that describes the level of pain is. There's a name for it, right? Right. One of you guys probably has some nursing experience or some medical experience. I'll have to look that up. I keep forgetting whose scale that is at, but I'll have to check that out. Okay, so at any rate, I see a question there. I'll get to it in a second. Ordinal variables, do you smoke? How many cups of coffee? What's your blood pressure? How would you rate the MPH program? We already discussed that that's an ordinal variable. Okay, I had a question. Discrete or scalar can be negative integer as well. That's a good question. I usually don't associate discrete numerical variables with negative numbers because normally, when we're doing surveys and stuff like that, usually we're doing counts of frequencies or events or number of siblings and stuff like that. So to be honest with you, I don't remember anybody asking. I suppose it's possible if it's a whole number. Like, for instance, if I asked you, what might happen here? How many automobiles did you buy or sell this year? And you sold 2, didn't buy any. Maybe you would put it in a -2. So I guess it's possible to have a discrete numerical variable that's negative, but I don't think it comes up very often. Certainly, we're not going to try and trick you with something like that anyway, for sure. Okay, so now we're going to refer to, a lot of people did the first 2 items here correctly, but then got a little mixed up on the second part. So I'm going to open up I guess, referring to the charts. I think that's the president's. Is that what that is? Let me see. I have it on my desktop, I believe. Here's the president's chart. You guys figured out like what chart you had to use, even though I guess I gave you the wrong name there in the description. Okay, so the first question that we have is oh, I'm sorry. There is a different chart. Let me see if I have it. Let me see if I can't find it in the charts. Oh, there we go. Okay, that's what we're looking for. Okay, let's go back to the question. I jumped ahead. I was thinking about a different question. Referring to the image charts.pdf provided with the assignment, fill in the blanks on each page of charts.pdf. Plots of 16 samples, each with this sample size of 20, of a quantitative variable from the same population is shown. Differences you observe on a single page are due to sampling variation, which is a central concept in statistics. Every time you sample a population, you tend to get roughly the same mean, same median, but you don't always get exactly the same result. So based on what you see there, we're asking you to try and characterize the population based on the samples that are listed on each of the 3 or 4 pages that are there. And they're kind of grouped together because we're looking for we're looking for you to respond with specific properties. First of all, what kind of charts are these? Right? All of these charts were, right? Well, you can see it right there. All the charts are histograms, right? That first one looks like a very nice normal distribution. Okay, plots that look closest to normal distribution are labeled with the letter. Okay, let's take a look at this. Let's see. A looks pretty normal. B, not so much. We got a little extra over here, a little short over there. And C really doesn't look normal. There's something weird going on there. So clearly, looks like A is the one that looks most like a normal distribution. Histograms with the variable B are not symmetrical. They are skewed. Well, let's take a look at it. There's B. It's skewed. So we know that values that are far away from the mean tend to pull the mean away from the median. So which direction are the values that are pulling stuff away from the middle values? Well, up here we have these high values are far away from where we think the middle values are. So these guys over here, these 2 or 3 individuals over here, are pulling the average up away from the mean. So they're skewing the average, the mean, to the right or positively. Usually in this direction we refer to as positive, and in the left direction we refer to as negative. So this is a positively skewed distribution. Okay, so I'm going to click that in, and the other answer that would be correct would be a right skewed distribution. Either answer would be equally correct. Okay, histograms for variable C are an example of what kind of distribution. Okay, it took 2 kinds of answers there, right? Well, we see that there's two values that represent very frequent outcomes to the frequency for this particular distribution. So instead of one big peak in the middle, as we had in these normal distributions, right, we have 2 peaks, right? So you might refer to that as bimodal. What's another name for it? I also accepted another name that a few guys gave it. Anybody got an alternative for that? Okay, could be that doesn't necessarily have to be just 2 peaks. Could be 3 peaks or 4 peaks, right? If we have more than 2 peaks, what might you refer to it as? Anybody have an opinion? Long week. I guess it's been a long week this week, so I'm having trouble pulling this. Thank you. Multimodal. Good. Exactly. Okay, good. Bimodal, multimodal, same thing. More than one mode. Mode being the most frequent value. Okay, so let's look at the next one. Next one, we're examining again what a histogram looks like. These are all exercises that are kind of getting you used to working with histograms and data that's displayed graphically. Okay, so let's see what the questions are here. Presidents represent the ages at inauguration of 44 presidents. Which range or bin? Each one of these different columns represents a bin, a group of numbers. Or the number of presidents, the frequency, the number of presidents, in this case, 17 presidents were inaugurated when they were between 55 and 59 years old. Only one president was inaugurated when he was over 70. Okay, so the range or bin, which range or bin contains the median age for a president at their inauguration? Well, the median age is, of course, the middle value. So if you have 44 presidents, the middle value is going to be between 22 and 23. So basically, we have to find 23rd oldest president or 23rd youngest, 22nd or 23rd oldest or youngest president. I'm going to stick with 22 for our purposes. We know that if it's an even number of people in the sample, then you kind of there is no middle value. You have to average the 2 that are on either side of the middle. Okay, so let's see which ones. How would we get to the 22nd president? Well, counting up from the bottom, okay, there's 2 presidents there. That is 5 presidents there, so we're up to 7. There's 10 presidents here, we're up to 17. So in this bin, there is all the presidents from the 18th oldest to this is 17. And what did I say that was? 7? Did I say 7? 17 and 17. Everything from the 18th to the 34th oldest president. So the median, the middle president, is in here. Can we tell what his age was? No, but we do know he's within this bin. Okay, so that's going to be 55 to 59. If I make a mistake here, let me know and I'll go back and correct it. What percentage of these 44 presidents were 60 years old or older at their inauguration? Well, 60 years or older. There's 5 presidents that were between 60 and 64. There's 4 that were between 65 and 69. So that's we're up to 9, and we have 1 over 70, so we're up to 10. So 10 out of the 44 are were older, were 60 years or older. So 10 out of 44. And of course, you could express that as a percentage or a probability. So that's going to be 10 divided by 44 is equal to about 23%. I'm going to round it for our purposes, 23%. Okay, so next question. Interrupt me if you have a problem. Next question, which bin or range contains the 25th percentile and the 75th percentile? I'm going to ask you a quick question. What's the percentile for the median? What's the percentile for the median value? Right? 50th percentile, right? Exactly. So the 25th percentile is just halfway between the median and the first value. So basically, the median would be the 22nd. So the 25th percentile would be the 11th value, and the 75th percentile would be the 33rd value. Okay, so each one of them are 11 apart, because there's 44 presidents divided up into quarters. Okay, so 25th and 75th. So where is that? Let's see, we got to get to the 11th. So we got 2, we're up to 7 here. So the 11th president is going to be in the range 50 to 54. And now we're going to get now to the 33rd president. I'm going to do something a little bit different. I could count up from the bottom, but I got to count a lot of numbers. That's just 11 from the top, isn't it? Would be the 33rd president. So we got 5 here. We got 4 here. That's fine. 10. So 11 from the top is going to be in 55, 59. So the 25th percentile president is in this bin, and the 75th percentile president is in this bin. Coincidentally, the same bin is where the median is, right? Not exactly a perfectly normal distribution, but this is what we have to work with. Okay, so 50 to 54 and 55 to 59. 50 to 54 and 75th plus 55 to 59. Okay, so, and finally, probability that a president was collecting Social Security. In other words, he's over 65. Things have changed a little bit. Right now, you don't collect until you're 66, or at least you don't collect full Social Security until you're 66. So things have changed since a couple of years ago when we started using this question. 65-year-old, given that he was among those that were 50 and older when inaugurated. What do we have here? What kind of probability is this? This is a conditional probability. What's the probability that he's over 65, given that we're only looking at presidents that were older than 50? Okay, let's go back to the chart. What presidents were older than 50? Well, all but these 2 are older than 50. So instead of 44, we only have a pool of 5 and 2, 7, right? So that leaves 37 presidents that were older than 50. How many were older than 65? 65 or older. Well, out of those 37, see, 4 and 1, 5 out of 37 presidents were older than 65. We're older than 65. So that's our conditional probability. 5 out of 37. And let's see, what's that percentage? Get our calculator. Okay, but did I make a mistake here? Was it 5 out of 37? 65, 5, and was that 50? Was that 50 and older? 50 and older. 10, 17, 17, and 10 is 27. Nope. 10, 27, and 10, 37. I'm right? Did I make a mistake there? Am I right? 14%? It's correct. 13.5%. Yeah, well, I have a vague recollection that I originally put in for the answer 13%. Let me try this again. Maybe I had the wrong number. So what was it again? The answer is 5 divided by 37. Yeah, well, how did I get 14% there? Yep, 13.5%. I must, well, I play it back. I'll be able to see. It's one nice thing about this. When you screw up, everybody knows it because you can just play it back as often as you want. Okay, about 13.5%. Okay, so hopefully we didn't have too much trouble with that. That was a little challenging, the last couple of things, but it gives you a little understanding of what we mean by percentiles and our first look at conditional probability. Okay, question 7. Using the data provided in a file, descriptive statistics.excel, use Excel to calculate the mean, median, mode, variance, standard deviation, minimum, maximum, you name it. In fact, I think that if I recall correctly, I actually gave you I've kind of filled out a table for you in here so that you could fill in the blanks kind of rather than have to keep looking back. See if I got the right one. Here we go. One or two people grabbed the wrong file. I'm not sure how they did that. Perhaps the lab file, one of the lab files that we used might have had the same name, and a couple of people did use that. I tried not to penalize them for it, but if you did that and I took any points off, or you think I took any points off, you'll be able to go back and kind of go over it and try and figure out like where you lost a couple of points later on. But if that happens, just let me know and I'll go back and look at it. I don't mind going back and checking, and I'll go back and look at it. Okay, so let's take a look at this. Let me see here. I want to keep the chat window open so I can see if you're asking anything. So the mean is equal to the arithmetic average. I want to put a function in the cell. I check the equal sign. I can either go up and search for the function f of x, but I know that the function is average. Parentheses, and I'm going to average this group of numbers. Okay, average is 68.9. The median equals median. Again, there's a function in Excel for median. And I can find the median. The mode is also a function for mode. Parentheses. And if you don't remember this, or are not sure if there is one, you can start typing in what you think is the correct value. Like, for instance, on here, I'm going to do minimum. Minimum, right? Well, look, it's giving me a suggestion for functions that are available. Oh, looks like minimum might be right where I need. When I hit the first parentheses, it gives me a hint as to what numbers to fill in. Just a list of numbers, number 1, number 2, number 3, and so on. So I find the minimum. If you're really stuck, you can go up to f of x. You can actually search through all the library of functions that Excel has. And if you click on it, it actually gives you a little help screen. Okay, maximum. Let's give max a try. And in fact, there is a max. And the range is, of course, just the difference between those two. So since usually the range is expressed as a positive number, I'm going to subtract the minimum from the maximum. So I'm going to click the maximum first minus the minimum. Okay, range is 10. Okay, now the variance. How do I figure out the variance? The variance is equal to, see if there's a value for variance. Well, sure enough, there's a VAR. There's various different forms of variance. Don't worry about that for now. For our purposes, we're just interested in the variance of a simple list of numbers. Standard deviation, STDEV, if I'm correct, and in fact there is. Okay, and highlight them all. There we go. Now, one other way you could have gotten the variance is the standard deviation. The standard deviation is equal to the square root of the variance. Okay, we remember we learned that as we were going through the actual process of calculating these values from the raw distribution and mean. Okay, 25th percentile. Well, 25th, what we're really after here is we want to know what the interquartile range is. And the interquartile range is the values between the 25th and the 75th percentile, the middle 50% of the results. Okay, so in order to find the middle 50%, we're going to find the 25th and the 75th percentile. The 25th percentile is equal to, there is a function called percentile. Okay, and I'm not gonna use any of the exotic ones, just percentile is good enough. Now it's asking for, I don't know if you can see that very well, array and K. Array basically means a list of numbers. Doesn't have to be a list. It could be a block of numbers like that. See how it fills in a block? The block of numbers could be a bunch of numbers that don't necessarily have to be in a single column, or it could just be that column as it is in this case. So the percentile of this list of numbers, what percentile? Well, that's what the K is. It wants to know what percentile you want. That's expressed as a decimal. 25th percentile is expressed as 0.25. Now, if you didn't know that, you could go up to f of x, open that box, check on percentile, and it'll bring up a window that'll help you with how it should be inputted. Okay, that's 67 to 25th percentile equal percentile, parentheses, and I'm going to do the same thing again, comma, 0.75 for the 75th percentile. Oops. And 73, and the interquartile range is going to be 73 minus 67, or 6. Now, some of you may have noticed that when you go through the same exercise in SPSS, it gives you a decimal value for 6. And, you know, any of these boxes, you can, for instance, these boxes right here, you can highlight those boxes and you can go up to Format, Cells, and you can tell it, for this number, I want, let's say, 1 decimal place. And it'll reformat those. It'll store all the information. All of the information, the 13.3, whatever it was, is still there, right? But it'll display it as that number rounded to 1 decimal place. Okay, let's just check to make sure that this is more than 1 decimal place. Format, cells, okay, because that could be one problem. That could be one reason. I'll leave it it starts off with none. It may start off with anything, but then it defaults figuring most people are working with money, so that you're going to use 2 decimal places. So I'll say 3. Let's say 3 just for the hell of it. Okay, see what we get. Okay, well, they're all whole numbers. Now, it's possible that Excel calculates the interquartile range, the percentiles, differently than SPSS does. Excel may look for the actual value that's closest to the 25th percentile, while SPSS looks for, it actually interpolates that if it's really between 67 and 68, it will give you a fractional value for it as if you were looking at an entire population. So that's the reason some of you may have gotten a slightly different result, like 6.2 or 6.5 or something like that when you use the interquartile range when you use SPSS. We're going to take a look at that. So I'm going to save this, save as, Descriptive Statistics 1, and I'll call it Answers, Solution. And I'll post this later on. So you have the actual file, and you can click in there and see the formulas that I used. Okay, so that's good. That's not so much work. Good for 15 points, right? Okay, so upload your Excel file here. You would, if for those of you who have difficulty with this, you just click Browse Your Computer, and you would go to your desktop, find that file. Do it this way. Find that file, click OK, and it would be uploaded to Blackboard. So then I could go ahead and do the grading. Now, just so you know why, occasionally you see a funny grade, and then I go back and I correct it, and so on and so forth. I'll show you that. Show you the grading process when I get to this. Actually, I can't show you the grading process without showing everybody's grades, so I'm not going to do that. But Blackboard, for instance, will look for these 2 words. I can tell it that the correct word could be positively, could be right? But if you capitalize right, might not recognize it. You put positively or right. Type that in. I might not recognize it as positively or and right. So it does some funny stuff. So occasionally I get an email from, as I did today, from a student says, can you help me out? I don't know what I got wrong, and I wound up with a 72 or something like that. And it was one of the ones that I hadn't yet reviewed to check the answers and stuff like that. Found out it was a 96, not a 72. So Blackboard can do some funny stuff. So, but don't freak out. I'll always say go back and take a look at it. Even if it's a month from now, we can go back. I'm perfectly willing to go back and check it. Okay. So, but don't, I prefer you don't get crazy about grades at this stage. Just keep it up. Keep up with the homeworks and stuff like that, and I think you'll do pretty well. Okay. Repeat the calculation in the previous problem using SPSS, R, or any other statistical software that you're going to use. And by what statistical software that you're going to use, I mean software that if you had the same problem on a test that you would want to use on a test. And the reason why I'm doing this is because I'm prepping you for the test, basically, obvious. Okay, so let's see if I have another version of this. So it's an Excel file. Do I have the? Well, I think I gave you copies of it as an SPSS file. So all you have to do is double click the file and opens an SPSS. I don't have it on my desktop right now, but what I can do, I can get a little sneaky here, and I can go to SPSS. I'm going to open up the SPSS eventually. Oh, still bouncing. Okay, here we go. All right, we get this basic startup window. I don't like using this. I prefer to just open stuff myself. I'm going to say open data. Now, you're not going to have to do this on the test. We will give you files that will be in the format that you need to work in. But just so you know how to do this, I'm going to go to my desktop. Okay, and I don't see that descriptive statistics file here. That's because it's only seeing SPSS files right now, .save files. So I'm going to tell, show me any Excel files that are on my desktop. And here we go. Here's the Excel file I'm interested in. And say, let's open that file. Let's import that into SPSS. Okay, now it sees information between A1 and H18. We know that that's all the rest of that detritus that not really is part of the data. So I actually want the range A1 through A10 to be imported. So I'm going to type that in there. If only those numbers were in there, it would have said A1 through A10. It's just that all that other stuff is there right now. Now, I happen to remember that the top row is not a variable name in that file. So I'm going to uncheck that. If you leave that checked, it's going to take the top value, whatever it was, 68, for instance, and it's going to make that the variable name. In fact, I don't think it'll actually probably just give you an error because I think it insists on having a letter, alpha character, be the start of a variable name, but I could be wrong. But in any case, it's going to cause a problem. So I got to uncheck that so it actually looks at all of those as numbers. I'm going to click OK. I'm going to cross my fingers, and we're in the variable view. It recognizes it as a numeric and a scalar variable. That's good. I'm going to go to the data view, and there are my 10 numbers right there. It gave it the variable name V1 because I hadn't given it a name. I could go to the variable name now, and I could go in there and change that to whatever it is. Maybe it's height, right? Could be anything, but why don't I call it height? Okay, so I'm going to go back to data view. Okay, there are my numbers. Now, I want to find all of those. I want to find the mean, the median, and so on and so forth. I'm going to do now that to answer a question that we had earlier. And let me make sure there's no more there right now. It's trying to make sure I go back and look. Okay, analyze. Now I have a bunch of choices here. Descriptive statistics seems like a natural, right? And frequencies is just a count. It'll only count how often a value comes up. Frequencies is really intended for nominal variables, nominal or categorical variables. Things like male or female. It's going to count how many males, how many females. It's not going to find averages. Silly as it is, if you look under statistics, SPSS will find averages, means for frequencies. It really doesn't make much sense for the most part. Say, for instance, for male and female, If there's 17 males and 34 females, whatever number of males and females and stuff, what's the average of males and females? I guess you could argue it's, the average is someone with one testicle and one breast or something like that. But it's nonsensical. It doesn't mean anything, right? So I wouldn't use this for height, because if I use it for height, it'll see all these different values. It may notice that the number 67 comes up twice, but it's really not going to give us any useful information. I'll do it anyway just to show you what it comes up with. See, it comes up with, 65 comes up twice, 67 comes up twice, 73 comes up 3 times. I guess you found out what the mode was anyway, but that's really the intention here, is to use frequencies for nominal variables, not numerical variables. Okay, I'm going to go back to my data, say analyze. Instead of frequencies, I'm going to go to descriptives. I'm going to see what values that gives me. I'll click descriptives. It gives me, now very often in real life, you're going to find a whole list of variables in this left box. Name, age, height, weight, BMI, marital status, so on and so forth, all a bunch of variables. And SPSS doesn't know which one you want to work with. So they'll be listed on this side, and you simply choose the one you want, or choose the ones you want in multiple, and move them over to the right, so SPSS now knows you want to work with that variable. Will find a descriptive statistic for that variable, and I'm going to click OK. Okay, now SPSS calculates our descriptive statistics. Let me see if I can fold this up a little bit so we can see it a little higher. Okay, and what is it? Well, the mean is 69.8, same as we got before. Minimum, maximum, standard deviation. There's a lot of things missing here that we didn't get before, right? That we got before when we were in Excel, right? Things that didn't calculate. This is just your basic descriptive statistics. If you want to explore the data more, maybe you can look at it that way. You want to explore the data in more depth. Let's go to Analyze, Descriptive Statistics. And instead of stopping at just descriptives, let's go to Explore. Well, now you got a number of boxes here. It's the same as before. The dependence list is the same as that box to the right that we had in Descriptive Statistics, Descriptives. I'm going to move height into that box. Now, we may want some extra information. We're going to explore this data a little bit more. I'm going to click on Statistics, and it's already checked off to give you the descriptive statistics. There are some other things that we're going to use later on, but for right now, I just want to make sure it gives me the descriptive statistics. Well, on the plots, well, it's already going to give me a stem and leaf plot, and just a secret between you and me, it's automatically going to do box plots, right? So you don't have to check anything off for it, but you can ask it to do a histogram for this list of numbers. Okay, and I'm going to click Continue. And there are some options. Mostly it's got to do with what to do if they're missing values and stuff like that. Somebody didn't give you their height or so on and so forth. How to handle that. But we're not going to worry about that. It'll come up later on. Okay, so right now I can display just the statistics, just the plots, or both. I'm going to click both and say OK. So in addition to statistics we got before, now we got a whole bunch of information. The mean, the median, the variance, the standard deviation. Notice these are all the same numbers we got before, 69, 75. The range, the interquartile range, you came up with 7 instead of 6, right? As I mentioned before, he calculates it just a little bit differently. And some others that we haven't looked at, really, skewness and kurtosis and so on and so forth. It created a histogram. This is a really small data set, so the expectation is that it wouldn't have come. It doesn't seem very likely that it would have come out as appearing much like a normal distribution. Also drops in this information on it. Okay, and there's our box plot, right? So since the question was calculate the same statistics, repeat the same statistics as you did before, well, we didn't ask us to do these plots and so on and so forth. So all the question asked us for was the information that's in this box. I'm going to click that box, right? I'm going to open up Word, and I'm going to be a little frustrated because when I open that up, I opened up the last file I had. Let me get that out of the way. New blank document. Okay. When I open that up, I'm going to click on that, and I'm going to say copy. Then I'm going to click on my Word document, and I'm going to say paste. Now, normally what I would ask you to do, I would say click, instead of saying paste, you could say paste and it'll paste it in, right? The only problem is that, see all these tabs and stuff like that up there? If I want to, like, make this a little neater, or if this is too wide or something like that, it's a little bit awkward to work with. And it's also awkward to move it around the document. Okay. However, the good thing about just pasting it in that way is that I can go in if I want to. I can highlight stuff. I can change colors. I can reformat things, and so on and so forth. Okay, let's make that red. Right. Yeah, I can reformat it, highlight things, and so on and so forth. The downside is if this went off the page, it's really hard for me. So if it had like 7 columns and it ran off the page, it'd be really difficult for me to reformat. The alternative to just saying paste is to say edit, paste special. Now, if you're using a newer version of Word, that'll be in the ribbon. There'll be a little box over here. And instead of saying, here, let me show you. Okay, on the ribbon here, there would be a little box that says, do I have it here? It's hidden somewhere else on this version, maybe. No, it should be on home screen. I may not have this spread out enough. But instead of that, you'll have a little clipboard that you can click on, and you can paste it in, or you can hit an arrow, right, and kind of like this, and it'll give you a bunch of choices. One of the choices will be paste special. Okay, so now in my case, I'm going to choose edit and paste special, right? And I have a bunch of choices. I can put it in as formatted text, which is the way it did it. I could put it in as unformatted text, which is just the numbers and the letters unformatted, right? Or I could put it in as, and this is kind of like a problem I have with, there's a bug in my version of SPSS. When I say paste special, it only stores the information from copying out of SPSS in these forms. It doesn't give me the option of pasting it in as a picture. There may be an update or a patch that I need to install to make it work, right? So I can't do that right now. So I'm stuck. There are many ways to skin a cat on computers. On Macintoshes, for instance, they have a program which is kind of a screen capture program called Grab, and you can say grab a selection, for instance. So I can tell it, grab this box right here, right? And I can save that as a TIFF file. I'm not going to, TIFF file is kind of like a picture format. Okay, I'm going to save it as, just call it 1, and I'll drop it on the desktop. Okay, and then I can paste that into Word. I can certainly open a Word document if I got it. So if you've got a similar problem to what I have, this is the way you can kind of work around it. Let's see. Where is my Word document now? It's hidden by, things are getting piled up here so high that I don't need this anymore because I saved it. Nope, that's not it. Don't need that anymore. Get rid of that. That's my output. Where'd it go? There it is. Okay. Oops, no, that's that. I can go up here to insert. I can insert a picture, and I can go find my picture on my desktop. There it is, and paste it into my Word document. Now, the downside of the good side about doing that is, look how easy this is. If it were extending over, look how easy it is to resize it so it fits in the window, right? And it's very easy to move around to other portions of the document, just drag it around and so on and so forth. The downside is since it's a picture, I can't go in here and edit these words or these numbers or the formatting because it's no longer an editable format. It's no longer text. Okay, so you can choose which one of them works best, and you use it situational. One way works best sometimes, the other way works best another time. Okay, so I'm going to save that. Okay, descriptives. 2. Solutions. Okay, drop it on the desktop because I'll upload it later on. Okay, and I'm going to close this, get it out of the way. I'm going to close this. Okay, so next. Let's see our next question. Okay, and again, you would upload this to Blackboard so that I could open the file and then correct it and check it to make sure it's correct. That we uploaded there. So we're up to number 8 now, I think. Okay, repeat the calculation using answers. Nope, we're up to 9 actually. Okay, we're up to 9. Using the file ncbirthmod.sav, that complete the exercise we started in the class lab session. Copy the appropriate tables of graph into a Word document. Upload it. So we had a document. Then we had a exercise where we opened this file in SPSS, and you would be given the file in SPSS format, so you don't have to import it. And where is it? I have it on my desktop here somewhere. Here it is. There it is. Here it is, open in SPSS. And let's see. Somebody help me. You're going to have to help me with this. We know that we're going to want to use analyze, descriptive statistics, and I think the first thing that we ask you is something that requires frequency, something that has to do with nominal variables. Is it the number of married and divorced? Anybody remember what the variable was for the first part of that question? Anybody remember the Anybody remember the variable that we had to choose? Was it male, female for the first part of this? I have to shout because I'm not. The age of no, I don't think it was. Age of the mother was the numerical part of this. But I think first we asked whether or not the mother smoked. That's it. Thank you, Porva. I had to yell in there to wake you guys up. When I was younger, even younger than you guys are now, I had a job working at a pizzeria on the boardwalk in Brighton Beach. And it was right on the boardwalk. So we were right off the beach and stuff like that. So all summer long, it's a great summer, a great couple of summers actually. All summer long, we would be working during the daytime in this thing. We'd have the radio on. And back in those days, there was just AM radio. There was no FM radio. And everybody listened to one of two stations, two rock and roll stations. One was WMCA, and the other one was WABC. Cousin Brucey was on WMCA, and this other group of guys called the Good Guys, the WMCA Good Guys were on WMCA. And there were a lot of other, number of other really popular disc jockeys. But there was one group on, I think the guys on WMCA, was because so many people were listening on transistor radios on the beach that every half hour they would all shout in the microphone together, turn over. So that if you're sitting on the beach, you're not going to fall asleep and fry. So that I kind of feel like if I suddenly talk louder trying to get a response, I kind of feel like I'm one of those disc jockeys yelling, turn over. Hang on a second. So smoking. So we want to get that variable smoke. Remember, we chose frequencies here. Smoked during pregnancy. So there are two values there. They either did smoke or they didn't smoke. I'm going to move that into the box of the variables that we're interested in. And the statistics, I don't want any of that stuff because we're just interested in the nominal variable. Charts, I don't know. Let's do a bar chart. Okay, I could ask it to do a pie chart. Let's do a bar chart. And we could ask it to do it as percentages or as frequencies. Frequencies, actually, the height of the bar is the number of people. The percentages represents the percentage of people. But it should come out basically the same shape. So I'm going to click OK. And sure enough, there's our result. We get our frequencies, the actual number of people and percentages that smoked or did not smoke. 684 did not, 114 did smoke. This is a number of years ago, and so on and so forth. And that's what it looks like graphically. And again, you can copy and paste this into a Word document. Okay, so next, I think we looked at the age. I don't think it was the age of the mother. We examined the weight of the babies depending on whether the mothers smoked or not, if I'm correct. So I'm going to go to Analyze, Descriptive Statistics, Explore. Okay, so the first thing I'm going to do is I'm going to look at the weight of the child at birth, right? Could be ounces, could be grams. Weight of the child at birth, I'm going to put that into the dependence list. And I'm going to tell it, gee, let's go into statistics. Oh, that's already checked off descriptives. Let's go into plots. I want a histogram for that. Okay, and I'm going to say, okay, that's enough. Plot both. I'm going to say, okay. Okay, and it's going to create the same kind of chart for me. The average weight for all the babies, not just the mothers that smoked, all the babies is 116 ounces, and the median is 118 ounces, and the standard deviation is 22 ounces, and so on and so forth. And here's our distribution. In this case, this is skewed to the left. Not so surprising because you probably have a lot more preemies than you do babies that are much, much larger than normal. So these preemies are pulling the weight, the average weight down, so it's skewed to the left, okay, or negatively. And that's the stem and leaf plot is kind of another version of that. And you'll notice, look at all these outliers. Those are all premature births that were so different from the mean that SPSS is kind of telling you, hey, gee, maybe in order to examine this as normal distribution, we need to exclude these, in our consideration. Maybe there's a reason, a special reason why these are so dramatically different. But we're not going to worry about that right now. Okay, so it did this for the entire data set, all of the babies. Now, maybe what we're really interested in is comparing mothers that smoke to mothers that don't smoke. So I'm going to go back up here. I'm going to say Analyze, Descriptive Statistics, Explore. And Explore gives us another powerful option. And that is this second box says Factor List. A factor list means break it up into two groups or break it up into multiple groups. And usually you're going to put a nominal variable in here. Break it up by gender, male or female. Break it up by ethnicity. Break it up by country of origin, right? And it'll break up all of these values. It'll analyze all of the weights of the children separately for each country, for each gender, for smokers and non-smokers. So we're going to go for smokers. Smoke during pregnancy is going to be on the nominal variable. Notice SPSS helps us out. This little thing with the red, yellow, and blue, that's nominal. That represents a nominal variable, and that ruler represents a numerical variable. Again, statistics is checked, descriptive statistics. Plots, well, it remembered, so it's going to do the histogram again. And we know it's going to do side-by-side plots automatically. We don't have to tell it to. Display is both. I'm going to click OK. And this is the remainder of the information that you were asked to produce when you were working with SPSS within this particular problem. Here's the mean for mothers who did not smoke, 117. Here's the mean for mothers who did smoke during pregnancy, 109. They tended to have, on average, smaller babies than non-smoking mothers. Is that a significant difference? Well, 8 ounces, 8 ounces, that's 10% of body weight stuff almost here, right? So, or 8% body weight, so that seems clinically somewhat significant. But for right now, we won't worry about whether it's statistically significant because that's something we're going to be working on in the coming weeks. Our histogram, well, it actually does a histogram for each different group, right? This is a histogram for babies that were born to mothers that didn't smoke. And this is a histogram for babies that were born to mothers who did smoke, right? A little bit different. And here's our box plots. And if you look over here, it looks that mothers who did not smoke, the median weight was higher than for mothers who did smoke. We kind of knew that already, right? Because we looked at the statistics that we calculated. So we would copy and paste each one of the boxes as we would need it into SPSS. Okay, so I think you guys got that. Are you okay with that? Because I think that's basically what the homework consisted of. Now, notice over here, I am going to, because I'm going to close this for starters. Okay, close tabs. Changing confirm, leave the answer may not be saved. I'm going to stay on that. I'm just going to minimize it. I want to print that out. Okay, I'm not going to need this file anymore. And SPSS, I'm not going to need anymore. Okay, so now save contents of output viewer to output 1. I'm going to say yes. The reason why I'm going to say yes is because maybe I want to use this file later on. I'm going to save it to the desktop. If I don't save the output file, then I won't have all of those graphs and so on and so forth. Now, unfortunately, SPSS is very uncooperative of sharing output files between different versions of the program. That's why I ask you, one of the reasons, besides the fact that you really should be doing it because that's the way you would most likely use this in the future. That's why I ask you to copy the boxes and paste them into a Word document the way you would in real life in another course or as part of your work or something like that as part of a research a project. And now it's asking me to save the data set. Notice you save the data window and the output window separately. If you don't save them both, then you won't have one. One of them obviously is then going to be missing. They're separate windows, separate file save files.